Alright, this mini lesson is on graphing rational functions, and I have a function right here, and it's a rational one. We have variables in the numerator and denominator, and the graph is shown in red. And a few things, well, when we graph these functions, we certainly want to use our calculator to our best advantage, and it will do a pretty good job sketching these, although it can be misleading at times and certainly doesn't show every detail that we need. The details that we're looking for in a good graph are, first of all, we have to know the equations for or the location of any vertical discontinuities. These discontinuities basically come in two flavors. They can either be asymptotes, and I've shown one right here. This is an asymptote. An asymptote is simply a line that you get very, very close to with your graph, but you never touch it or cross it. And so right here, if you notice, our graph is going up and outward to the left, but it's never going to quite reach that blue line, that blue dashed line. And that blue dashed line is an asymptote. This graph only has one vertical asymptote. There is a horizontal asymptote. That's the second thing we'll be looking for. But so you can again see an asymptote in action. Right here, this red line, the graph of this function, is trending upwards and to the left and getting close to that blue horizontal asymptote, but it never will touch it. Down here, it gets close to the asymptote again, but it never touches it. Another discontinuity that we want to look for or be careful of is holes. And a hole is just a point in the graph where x cannot equal that value. It's very similar to where we find asymptotes at, in terms of we have to look at our denominators quite frequently in these problems. If you look at the equation, though, it kind of gives us really big clues as to where these asymptotes, at least the vertical ones, and where these holes occur. This expression can be reduced to the following: 1 over x minus 2. This x plus 1 over x plus 1 will cancel out when you simplify it. But when this happens and you simplify it, you've got to keep track of the x value that you threw out that causes the denominator to be 0. In other words, if x is negative 1, that denominator becomes 0, but we can cancel that term out. And when that happens, that tells you where a hole is at. And so this hole right here in the graph is at x equals negative 1. The vertical asymptote we get by looking at what's left over in our denominator. In this case, at 2 would make this denominator 0, so we have a vertical asymptote at x equals 2, and that's why we have that dotted line going vertical right there. Horizontal asymptotes are a little bit tougher to determine. To determine horizontal asymptotes, you have to compare the degree of your numerator and the degree of your denominator. And let me just show you 3 quick functions here, and I'll explain where the asymptotes are. So here's our first function, x squared plus 1 over x. The degree of our numerator is 2. The degree of our denominator is 1. When this is the situation where the numerator's degree is higher, no horizontal asymptote. So we wouldn't have a horizontal line like that that we get really, really close to. Here's another function. Here you'll notice the degree of the numerator and degree of denominator are exactly the same. In that case, the horizontal asymptote is always going to be at y equals, and it's the coefficient ratio that tells us where to put that line. So y equals 3/4. So if this is the function we were graphing, we'd have a horizontal asymptote, right about here running through our graph. It'd be a dashed line. Okay, so there's if the they have equal degrees, and then we've covered where the top one's got the higher degree, where they have equal degrees, and the third thing that could happen is the denominator could have a bigger degree, so maybe 3x squared over 5x to the 5th. When your denominator has the bigger degree, here we're comparing the 2 to the 5, your horizontal will be always at y equals 0 right along the x-axis. Okay, so that's how we find our horizontals. And finally, x and y intercepts are what we've always done in the past. For an x-intercept, you let y equal 0 and solve it to find out what x is. And for a y-intercept, you let x equal 0 and solve it to find out what y is. So that's kind of a preview of what we're doing, and then in the next lesson, or the next mini lesson, I will actually apply these different things to a function from scratch, and we will graph it.